All right, welcome back to another episode of Let's See What We Can Tear Up Today. So I have an Xbox One. I think it's a model 1540. Model 1540. I bought this for $25, and the seller said that it doesn't do anything. They don't know what's wrong with it because they don't work on these. It seems pretty clean. I have not attempted to power it on, so I'm going to do it right now. I did buy me a power supply from good old Amazon because I didn't have one. So from watching videos, I think you're supposed to press this button to power it on, and then there's like an eject button right there maybe. I don't know. And it does not do anything, so not sure of all of the different things that can cause a no power issue. Other than, well, no power, you know what I'm saying? I mean, yeah. So I guess that's where we'll start. It's almost like like if you had a short or something on the 12 volt reel. I mean, it seems that your power supply would give you some kind of indication, but it does not. So I guess I will figure out how to take this thing apart. Nothing's in the board, so let's plug it in. Let's plug it in and see if the fan spins up. It does not. Wonder where voltage runs to in this thing. Am I getting voltage on the output? Let's find a multimeter. We're going to assume these are ground. Is this voltage coming out? I'm going to say no. Voltage coming out here. I'm going to say no. Okay, well, where does voltage come out then? Guess let's flip the board over and see maybe it's on the other side. Oh, here we go. Oh, did this thing get wet or something, man? Well, what's all this? You know what I'm saying? All of this right here. And right here. Looks like. And right here. I don't know. That might be normal. I've taken things apart before and looked at them and said, man, now that's something. That is something. Little crusties there. Yeah, there's some corrosion right here. This does not bode well for a repair. You know what I'm saying? Like something got hot right here. I think I'm gonna have to look at this under the microscope. To the naked eye, I should say, I don't see a tremendous amount of corrosion other than like right here. That seems to be the most significant amount, and that's on the ground. But you never know until you look under the microscope. So we got 5 volts on that pin, 5.2. And where does that go? I see a minus. I see a minus sign. What does that minus sign go to? Yeah, that's the only place I see 5 volts right there. Nowhere else do I see 5 volts. And I guess the question is where does that 5 volts go? Things that make you go. Alright, so let's check some voltages. So I know that just, watching other folks fix these things, around here somewhere I should have 1.8 volts. Actually, you know what? I should probably plug it in first, huh? So I have 1.8 volts there. I have nothing there. Oh, no, I have 1.1 volts there. Up here, I'm pretty sure I'm supposed to have 3.2 volts, and I don't have anything. Over here, I have 406 millivolts. On this inductor, I have 5.2 volts, but I'm pretty sure here or here I should have 0.3 volt or 3.2 volts or 3 volts, whatever it is. I'm not exactly certain. And I don't know if that's tied to these all of this power rail here, because I'm wanting to say this puts out 12 volts. And I don't think these are bad because the orange light on the power brick does not go off. So it's not like there's a short or something. But then again, I don't know if these are responsible for creating the 5 volts and the 3 volts and the 1 volts and all that kind of thing. So I'm not altogether certain. All right, so here's where I am at. So initially when I plugged this in, when I could see everything, I noticed that the fan did not bump at all. It didn't move at all. And so, every video I've ever watched, the fan, kind of spins. And if it doesn't, then that's an indication that there's something wrong with your 12 volts. So I checked every single MOSFET on my 12 volt rail, and none of them are shorted to ground. I checked the gate with respect to ground. So one meter was on ground, the other was on then the negative lead was on the gate, and they all read 0.6. And you would, when you reverse them, they get up to like 2 volts or whatever. So then it's almost as if my 12 volts is not being enabled. And as far as I understand, it's the 5 volts that enables your 12 volts. As I started checking my standby voltages, because what I believe is supposed to happen is when I plug this in, it generates the 5 volts, and then the 5 volts will generate a 5 volts enable signal back to my input power, and then it'll start producing 12 volts, and then that's what'll bump your fan, right? So I'm not getting clearly that 5 volts enable signal. So I found a diagram on the internet showing where you could measure all of your standby voltages. And so I'm going to go through and kind of show you what I'm looking at here, right? So up here, I should have my 5 volts. It's either this one or this one. It's that one. So that's my 5.2 volts, and as you can see, I'm getting that. And then they say you're supposed to also feel 5 volts on this second pin on this chip right here, and I do. And then on the back side of this chip, you're supposed to be getting 5 volts out. And if you notice, I'm getting 0.4 volts. And that 0.4 volts has fell all the way back over to this side of the board. So it clearly states that you should get 5 volts on the input and 5 volts on the output, but I'm not getting that. And then when I go to this chip down here, it's the exact same chip. I'm supposed to get 5.2 volts there, and I do. And then I'm supposed to get 5 volts on the output. But as you notice, I only get 1.4 volts on the output. So then when I look those chips up, those are actually 2 MOSFETs in one SOP or SO8 package. And so essentially what you have is these first 2 pins on this chip, pins 1 and 2 I think, are your gate and your source. So the first pin located right here, let's see if I can zoom in even further. So the first pin on this chip over here, that is your gate, and then next to it is the source, and then on the output is your drain. And so these 2 would be the drain for, I think, gate 2 and source 2. But in any event, they're MOSFETs essentially. And it appears that since all of your drains, regardless of what the inputs are 5 volts, you should be measuring 5 volts on any of these pins right here, and I'm not. I'm measuring 1.4 volts. So I guess my dilemma is I don't think these are bad, because when you look at the schematic of that chip, it shows you where the diode is in relation between source and gain, or source and drain. And so when I take the appropriate measurements with my multimeter in diode mode, I mean, I get the values that I'm supposed to get. So I don't think those are bad. And there's other people that have this problem as well, and they've changed out that chip, and it did not help the situation in any. I mean, I could reverse these chips and see if now this one will start putting out 1.4 volts and the other one puts out 0.4. But again, I don't think that that's the issue. One thing I do see is that, all right, so another unique thing I learned, on this chip, on the gate, I get 4.8 volts, and that's the gate again. On this gate, I get a full 5.2 volts. So it makes me wonder if I'm supposed to have a lower voltage on the gate than the source in order to cut this MOSFET on. What I did do was, so I injected 5 volts on the drains of those MOSFETs, and it drew like 900 milliamps or something like that. I didn't notice any life It did not enable the 12 volts. I did not see a bump in the fan. So then I started checking my 3.2 volts, because at first I thought I was missing that. So according to that diagram, you should have, these are diodes, so you should have voltage on one side. In this case, as you can see, I have 4.6 volts, and on this side I have 4 volts, and that 4 volts is going into this chip, and I believe this chip is producing my 3.2 volts. As you can see, when I measure that 3.2 volts there, I get it. And then that 3.2 volts is felt at this diode. And then when I go to the other side, and again, this is a diode, so it should have a drop, I get 0.403 volts. So, question is this diode bad? Or is there something after the diode that's causing it to not, the circuit not being able to complete or whatever? So, if I had another Xbox One, I could just pop and swap until I solve the problem, but I do not. So I'm having to try and actually figure this out. But I know that 3.2 volts is important because it goes to both my Blu-ray drive, whatever it is. And so that 3.2 volts is distributed throughout the board. It's supposed to be distributed down here. Well, you can't see that, but it seems like there are two distinct problems on this, but I suspect it's not two distinct problems. I suspect it's one problem that's causing both issues, maybe. But I'm going to try to find a shot. This is a Schottky diode. B2L1 is the nomenclature on it. It's a Schottky diode, and so Schottky diodes, apparently, from what I read, are just basically fast switching rectifiers, and they have a lower voltage drop than a normal silicon diode does. But you know, if I put a normal diode in there and I see, you know, 3 point something volts or 2 point something volts on the other side, then that to me is an indication then that diode is in fact bad. I mean, we may have multiple faulty components in this, but I don't know. There's so many little control mechanisms in place in these circuit boards that, you know, for example, what controls the gate voltage on that MOSFET? I'm pretty sure something controls the gate voltage. And is the thing that controls the gate voltage placing the proper voltage onto the gate of that MOSFET? And is that related to the 3.2 volts line? You know, because the 3.2 volt line might wind its way up to that diode. But anyhow, so yeah, that's where I'm at. That's my explanation. And I'm going to, once I figure out what to do, I will be back. Okay, so here's where I'm at. So I wasn't getting my 5 volts on the output of my MOSFET, and I'll try to use the microscope to show you some of this. That MOSFET is right here. I was not getting 5 volts on the output of that MOSFET, but the input of that MOSFET, I was getting 5.2 volts on the source and 5.2 volts on the gate, which was allowing me to get 0.4 volts on the output of this diode right here, or of this MOSFET. So then I started thinking, I'm like, well, you know what? Maybe if I lifted the leg of the gate, because maybe this MOSFET requires an absence of voltage to turn on. So I lifted the leg on that MOSFET. And so when I did that, I started getting 3.85 volts on the output of this MOSFET right here, which is whatever it is. I can't read the U4, B4, I think. So I plugged it in, still nothing. I still wasn't getting my 3.5 volts, nor was I getting my 5 volts. When I look at this, so my I was missing, I had 3.2 volts here, and I had right here as you were, I had 3.2 volts on the input of this diode, but on the output of that diode, I had 0.404, which I should have 3.2. So then I started tracing back, and I figured out that this leg of this diode corresponds to this small IC right here. And this
is a buck converter. And that diode comes in on these 3 pins right here. Well, when you look up the specs on that buck converter, those 3 pins are the output of this buck converter. And a buck converter needs 2 things. It needs voltage in, and it needs an enable signal. In this case, the enable signal was coming in on pin 15 right here. The voltage in was coming in on pin 16, pin 1, and pin 2. Let me use some tweezers to point to these. So the voltage coming in was coming in on pin 16, pin 1, and pin 2. Well, where does that get its feed from? Well, that gets its voltage from U3C1. It gets it from the output of U3C1, which is the same exact chip as the other chip that we were looking at. So it's set up the same way. This is my source pin, and this is my gate. The output of this MOSFET is what actually provides the voltage in for my buck converter. And my enable pin, it has to be something greater than 1.2 volts, I believe it said on the data sheet. So if you remember, this MOSFET was only putting out like 1.8 volts. And the input voltage for this, I think it said it was like 2.65 to 6 volts. So essentially, I think what was happening with the 3.2 volts is that this buck converter was not getting the proper amount of voltage from the MOSFET. So got a fella thinking, if the other MOSFET, if I lifted the leg and I increased the voltage on the output, what would happen if I increased basically I'm opening the gate so that that MOSFET will always be on. Now again, that's probably not safe, but this is for testing. So I traced the gate of this MOSFET, and it goes to the back of the board, and it goes through 2 resistors. Both of them are 10K, so it looks like a voltage divider network of 10K, and it's dropping the voltage down on the gate to like 4.8 volts, which is barely turning that MOSFET on, allowing like 1.8 volts to come out and feed the buck converter. So I lifted the leg, and so now I'll show this on the overhead. This is going to be some hellacious editing when I get around to putting this thing on YouTube. But so anyhow, now I want you to watch the fan when I plug it in. My fan twitched. So I'm getting 12 volts now. My power brick turned green. I still don't know how to cut this thing on. I guess I'll have to figure that out. But yeah, that is wild. So the next thing I have to figure out is what is controlling the gate of that MOSFET. I mean, I suspect it might be that other small chip that is also some sort of DC to DC converter of some sort, I suppose. Oh, but here, you know what? Let me do this again so we can start measuring voltage. So now that I've opened the leg, all right, I don't know which leads are for my multimeter. Now that I've opened my leg, let's get the multimeter in the shot so y'all can see what I'm talking about. Let's put it on top of the fan since we know it ain't gonna spin. All right, so it just cut off. I hope I didn't tear up anything. So I'm getting 3.2 or 4 volts there. Now I'm getting my 3.2 volts, as you can see, hopefully on the multimeter. I've dropped my 5 volts on the output here, but it cut off. So when it's on, when the power brick's on, I'm getting my 5 volts. Now it's going automatically to orange. Now it's going green to orange. So this thing has changed defects now. But anyhow, I thought that was pretty cool. I'm hoping the problem was it was overheating a while ago, because I felt the processor and it was hot. So let's see what happens now. Fan's still not spinning, still not cutting on. It is still not cutting on, but I'm definitely getting the 5 volts now. I checked the output. Nope, it cut back off. What is going on, man? That MOSFET might be getting hot. Stab a little alcohol on that. Plug it back in. No, you know what? I still think it's overheating because the fan's not spinning. And I don't know why the fan's not spinning. if it's on, you know, which clearly it's on because the processor's getting hot. So why isn't the fan spinning? All right, so back to the drawing board. All right, so I figured out that I was not pressing the right spot on the daughter board. We are going to try this again by pressing on the little deal. Oh Lord, I'm about to break something. All right, it's green. Is fan going to spin? Fan spins. Is it going to display anything on the TV or on the computer monitor? Come on, Bubba. Come on down. Oh, oh, oh. Yes! Yes! Let me see if I can move the camera. Look at that. It's probably going to give me some kind of error, but I don't care. I got this bad boy to cut on. Is it going to boot up, or what's it going to do? Oh, I have to figure out how to. Dude, this is the most amazing thing of all time. All right, so let's have one more discussion about this to make sure we're all on the same sheet of music. So the problem with this Xbox is that it was missing some of the standby voltages. But the problem is the standby voltage diagram that you find on the internet doesn't necessarily take into account the order in which things happen. And I may be wrong, but I solved this thing not powering on by tracing out all of these voltages. So the first thing and the most important thing about all of this is that I was missing 3.2 volts right here on the top side of whatever diode that is. I can't see it. And you can measure 3.2 volts coming out of here. And that 3.2 volts is felt on the cathode of that diode, but you're getting 0.404 volts on the anode. But that's because this buck converter was never turning on. And that buck converter was never turning on because this MOSFET was not producing enough voltage on its output. And the reason why that wasn't producing enough voltage on the output was because the input voltage on the gate was too high. It was at like 4.8 volts, 4.9 volts or something like that. So as soon as I lifted the leg on the gate, essentially powering this MOSFET on, as soon as I plugged in the system, then it started producing enough voltage to turn the buck converter on, which turned your 3.2 volts on, which allowed 5 volts to be felt on the output of this MOSFET, which produces your 5 volts enabled, which tells your power supply to cut on 12 volts, which supplies 12 volts to the 12 volt voltage rail that provides voltage to your processor. But here's the downside. By me doing that, as soon as I plug it in, I'm providing voltage to my CPU. So my CPU turns on. So if I don't cut on the system at the front panel, then my fan never kicks on. And if my fan never kicks on, then my CPU overheats. I know that's a lot to take in, but that is what I think is going on. So the key is to figure out what controls the voltage on the gate of this MOSFET. And it may very well be this chip right here, but I cannot find a direct link. As far as I can tell, this is tied to two 10K ohm resistors. But again, I'll approach this again. I'll keep digging, but I'm going to put this video out so that hopefully one of y'all may know and be able to point me in the right direction. So in any event, I hope you enjoyed this episode of I'm going to probably break something. But in this case, I actually didn't break it. I actually figured it out somewhat. So anyhow, thanks for watching.